Okay, welcome to the version control for researchers tutorial. I want to welcome you to ASB2020, the virtual ASB. My name is Ryan Alcantara. I'm from the University of Colorado, as well as Gary Bruening and Ross Wilkinson will help present today. This tutorial was put together with the help of a lot of people, but we're the three that will be talking to you today. So let's get started. Researchers are relying on more and more on custom programs to analyze data, and you see the phrase, we did blah, 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 using a custom MATLAB script in papers all the time. And although we rely on these scripts, many researchers don't have a computer science background or software development background, despite the fact that we are often developing software and for our research or a thesis project. Version control systems are a powerful tool that are commonplace in the world of software development, but can also help researchers manage and collaborate on code. So today our goal is to identify the vocabulary needed for you to go out and see and look at resources and learn from them, but also get some practice using the common functions and get an idea of what the concept of version control is. So hopefully you'll have the tools to explore some other resources by the end of this tutorial and apply them to your own projects. The outline for today is we will start with this introduction talk for a little bit, and then we'll move to Breakout 1, where you'll practice some of these functions and tools that I'm introducing. Then Ross will do a recap on what you've learned in that breakout room, and then Breakout 2 will learn about how we can use version control to undo changes made to an entire code base of multiple files. Lastly, Ross and Gary will talk about future considerations that we don't have time to cover in this tutorial in depth, but that are useful tools for your future applications. So let's jump into the question that everyone is wondering is, what is version control? In a sentence, it's a process of recording changes to a file so that you can recall those specific changes later. And there's more than one way to accomplish this. If we look here, we have a common situation, a familiar situation for people where the grad student thinks that they're done with their paper and they write it, they name it final.doc. And then they give it to their advisor and they get some revisions, and they now have a new version, which is revisions 2. This is version control in the sense, and it might work for just 2 files where you remember exactly what you wrote in the first version and the changes that occur in the second. But as you get more revisions and more revisions, the names of those files get out of control, and you start doubting why you even came to grad school in the first place. And so this is version control, but it's done poorly. The grad student and the advisor, for this matter, don't know the difference between the first file presented and the last file, why changes were made, or what lines specifically were changed. And although this is for a Word document in this example, the same thing happens with code. So if we have an analysis script like this one, someone might copy it and then make some changes and name it something different, like version 1, and then they make changes later and name it version 2. But there's no record of what makes version 1 different from version 2 and why were they changed in the first place. Luckily, you don't need to keep these records yourself because there's version control software like Git, which will do this for you. And essentially using Git allows us to undo any changes or identify changes made to code, which can be beneficial, especially for projects that are changing and files that are dynamic. So why use Git? First, it improves your project organization. So instead of having multiple files named different things, you have one file and you know that it works. It might have a long history, but that's hidden inside the Git inside the Git history component. So if you're working with other people, you can direct them to the one file that works and not have to clarify that version 1 is what you want for this task and version 2 is what you want for that task. Second, you can recall line-by-line changes. So if you are trying to figure out trying to debug, for example, you can see exactly where changes to scripts were made, not just a notification or not just an indication in the file name that something was changed. Next, you can use Git to synchronize code between collaborators. And you can do this by using Git in conjunction with GitHub. So GitHub is an online like server-based product where a script, for example, can be stored on GitHub, and it can be shared to two collaborators. And in each of these collaborators can make some changes independent of each other. And then Git allows those users to then merge these changes together and incorporate both of them into that same original file. And I'll talk a little bit more about this, but essentially using Git with a service like GitHub allows us to share and collaborate on code. Next, Git allows us to make safe changes to code. So you've got maybe some version of a script that you know works, and you might be timid or intimidated by the chance of like messing it up by introducing some new feature or adding something to it. So Git allows us to make copies of code and then make changes to them in an isolated environment. And once we feel confident that this function works, the feature works, we can reincorporate it back into that master version, the default version of your script. And you can, then your collaborators will be up to date on it. Lastly, a benefit of using Git is that you can revert files or entire projects back to a particular state. So it's not just like hitting the undo button on a given file, but you could revert an entire project back to a prior state. So for example, if you are getting some results with your statistical analysis for ASB, and you remember that this makes sense, and then some point down the line, things look a little different, you can go back in time and say, okay, what did it look like on August 4th? What did my entire project look like? So you can kind of roll back changes as needed. There's some terminology that I've been using, but I want to also introduce. One is what a repository is. You're going to see this a lot in the breakout rooms. It's often called a repo. This is really just a folder containing your project, or you can think of it as your project as a whole. So there can be, you'll have a project that might be locally stored on your computer, where you have the files physically on your computer, or that project or repository can exist on a server, like at GitHub, where we would call that a remote repository. Next is what Git is, and I've called it a version control software, but what it does is that it records changes to your local repository, to the files that are on your computer. And we can use this, like I said, with GitHub as a place, which is a place to store and host repositories remotely. And you can do that either just to back up your stuff, just in case, or to collaborate with people online. Next is what a commit is, or what committing changes is. Essentially, it's taking a snapshot of what your files in your repository look like at a given moment. So if we have our original example here with analysis and version 1 and version 2, in version control like terminology, we would call this first file commit number 1, where that file was initially added to the repository or to your project. Then any changes that were recorded would become commit 2 and commit 3 and so on and so forth. So what the history of your repository would look like if Git was tracking these changes would be that you have multiple commits, you know when those changes or snapshots were taken, who made those changes, as well as a little message, what we call a commit message, describing what exactly has been changed from that snapshot to the one prior. So this is the solution to just wading through versions and versions of files with different file names. This is an organized way of understanding and seeing what changes were made to a given file. So when Git is tracking a file on your computer, on your local repository, there are 3 states that files can exist within. And I have an analogy for this, so just bear with me as I describe this. But first, you have files that can be modified, or that are modified. This is essentially a file that you've changed, but the change hasn't been committed yet. It hasn't been included in a snapshot. To do so, you need to let Git know that you've flagged a file. You need to stage the file, but which is essentially flagging it and identifying it as a file to be included in the next snapshot. And then the last step is actually taking the picture, taking the snapshot, and committing those changes. So an analogy for this is, if you remember at ASB last year, we had a photo booth. And if you treat people, or you consider the people there at ASB as files, We can modify those files by putting on a mustache, putting on a hat, or maybe a mask or something. And so these people have now modified how they look. It's like how we would modify a file. Then once you decide that you have made the changes you like, either to you and your friends that are going to be in the picture, you all decide to get into the photo booth. This is essentially staging the files to be included in the snapshot that's going to be taken. Next is taking the picture, pressing the button, and committing those changes to memory and getting a little picture of them, and remembering now the state of you and your friends, for better or for worse, during the photo booth with the mask and the modifications. And this is a cyclical process because files are continually being changed. And so as you change a file, you stage it, and then you commit it. And so this is the process through which you are recording changes. And it's not like Google Docs where it's just recording every single keystroke change that's happened to your file. You need to be very deliberate in telling Git when to take a snapshot. And this works to your advantage in that you have a lot of control over what is included in a given snapshot. So it can, if you have a snapshot for every character that you change in the script, you might have to scroll through hundreds or thousands of these snapshots to find the one that you want. But if you can consolidate them into major changes, then it becomes easier to understand what the history of your project looks like if you need to go back and view some changes. So I've talked about Git as a way to track changes on your computer and GitHub as a way to like host your repository or your project remotely. I want to talk about some of the specific benefits and the dependencies of them. So when you're using Git and you're making these changes locally on your computer, a good reason to back them up on GitHub is in case your computer dies. So if your computer dies and you haven't had anything backed up on the cloud or backed up on GitHub, then your project and its history dies with it. So GitHub allows us to back them up easily and also share them with different people. Additionally, if you don't have internet access, that's okay because you'll still have access to the history of your local repository on your computer. So this can be beneficial if you are maybe traveling or don't have internet access at a given time. You don't need to be connected to GitHub to make changes and record them. It's just that when you want to back them up online or share them with a collaborator online, that you would need to essentially push your changes up to the cloud or up to the server. So next, I want to talk about what a basic workflow is. And this is more specific to how someone will work solo, but we'll incorporate it into a more collaborative setting right soon. So if we remember this like circle of life of how files can be modified, staged, and then committed, there are three conceptual areas that files can exist that correspond to this. And this is the working directory, where this is like the physical file that you, physical folder that you're working in, let's say in MATLAB or in Python or R. And then once you stage a file, it moves to this conceptual staging area. And then once it is committed, the record of it and that change is now stored in your local repository, and it's recorded there. So now I'm going to introduce some of the functions that you guys will use today, and these are the basic commands in Git that you'll be using, and you'll see them in any documentation that you look up, after this tutorial. So let's say we have a repository on GitHub or a project on GitHub. It exists at some URL. However, if you want to make changes to that, you need to have a copy on your local computer. The function that we use, or the command, is called Git Clone, and the syntax is very straightforward. Git space clone space the URL to that repository. And what that does is it copies it down to your computer so that there's now a repository locally on your machine that's being tracked by Git. It also technically puts it in your working directory since you can now access these files on your computer. So let's say we have a file in our working directory that we've cloned and we want to modify it. We add a couple lines. If we're satisfied with those changes and we want to start the process of recording them, we would add those files to the staging area using a function called Git Add. And if the syntax is, again, straightforward, Git space add space the file name. There are other ways to add multiple files, and those are going to be in your tutorial handout. But for now, just focus on typing in the file name for the given file that you've adjusted. Now, once you've staged it, you want to officially take the snapshot, commit these changes. The function is Git space commit. And what that does is it adds that change, records that change to your local repository. And this is that cyclical process. So you might do it for commit 1, you make another commit later, and then a third commit, and those changes are recorded locally and stored locally on your computer. However, if you want to back them up, the command that we use to push those changes up to the server on GitHub is Git Push. And so what this does is it updates GitHub with the changes that you have locally. Now there's also the possibility that there are changes on GitHub that you don't have locally, and you need to update what you have locally. The function that we use to do that, which is kind of the opposite of push, is to pull. So we're pulling changes from the online repository, the remote repository, to our local repository on our computer. So Git Pull and Git Push are kind of the inverse of each other. And I want to mention that Git Clone is only used at the beginning when you have no files on your computer and you want to just get an initial copy of the repository on your computer. So I'm going to go through real quickly what it's like to start a repository or open a repository on GitHub, and using Git Clone, Add, Commit, and Push to kind of go through this workflow so that you guys can reference it later. So if we first go to GitHub, here I am on my page, my GitHub page here. We can click this plus sign up top and say new repository. And a repository is like a project. So this could be one study, for example, or you could have one for your thesis. We'll call this one example, and we can give a description if we'd like. You can decide now if this repository is going to be public, meaning that other people can see it and potentially collaborate with you on it, or private, where it won't be searchable, but you could still invite collaborators. Depending on your account, whether it's set up with an educational, like a university email, you can have limited number of private repositories. In this case, we'll just have a public one, and we'll initialize this repository with a README, which just adds a text file there at the beginning. So we hit create repository. And just like that, GitHub now has a project called example. It's located at this URL here, and it contains one file, which is a README that says example. And you can see here, it just says hashtag space example. However, let's say we want to modify this file. To do so, we need a copy on our local computer. So what we can do is remember this URL, or you can copy it. But what we'll do is just open up Git Bash now and make this a little bit larger. And we will change our directory into our desktop just to find a location to put this repository on our computer. It can go anywhere you'd like though. And we will say Git Clone and type in the URL for our repository on GitHub. It is cloning that to our computer, and if we go to example here and list the files that are in there, we see that there is a README file located at desktop/example. And if you want to see that specifically, we can open up Finder here. We're in our desktop example, and now here's that README file. If we open this up, let's say with something lightweight like Notepad, we see we have the same text, hashtag space example. So now this file is in our working directory, and we have our local repository on our computer. Now let's modify a file. We'll say I love ASB, and we'll save it, and we can close it. We've now modified a file, and we're ready to add it to the staging area. The function to do that is Git Add, and we can type in README and hit enter. So now the file has been added to our staging area, and we're ready to commit it. You can say Git Commit -M indicates that we're going to include a little message here, and we'll say update README and hit enter. It lets us know that we've changed a file, which makes sense. We've changed the README file. And additionally, if we look at the log, the history of our repository, we see that there are two events. They're given these unique identifiers, and these are just a series of numbers and letters to identify a commit. So I've been using commit 1 and 2. This would be like commit 1, and this is commit 2, essentially. The first one is the initial commit where we added, where we even created the repository. And the second one has our message here where we have updated the README. And this information here in parentheses describes the different branches we're in, but we'll talk about that in just a second. So at this point, we are here. We've committed some change to our local repository. However, if I go to GitHub and refresh our page, the I love ASB isn't included here. So what we need to do is now push these changes to our repository using Git bash. So the function we use here, the function is Git Pull, Git Push. So we say Git Push, and once it lets us know that it's done, we can go back online, and if we refresh, we see that now the file has been updated on our repository. So we've essentially made some changes locally and pushed them up to the repository online. So that's the 3 steps you take to kind of update a repository with changes. You will add them to your staging area, you will commit them, and then once you're ready to store them on the server, you will push them up to GitHub. Now let's say, for example, that someone makes a change here on your repository and they don't believe you, so they say, no, really, I do love ASB. And they commit these changes, just to give us an example of someone that's made changes online. Now there are changes on our repository online that are not reflected in the file that we have on our computer. So in order to do that, we need to pull these changes down. So we can say Git Pull. It recognizes that there is a file here called README that's undergone some insertions of lines and a deletion of line, that the file has changed. And if we go back to our desktop and open up example and this README file, we see now that this file has the additional line of, no, really, I do love ASB. So that's kind of an example of what you guys are going to work through for your tutorial. I want to talk a little bit about collaboration now, but you can use this page as kind of a reference for the functions that you will be using, the commands that you'll be using, and how they kind of fit into your basic workflow. So next up is collaboration. So we asked you, how do you collaborate with using code or manuscripts? And we got things like we email the script back and forth. We change the name of the file, like we saw in the comment earlier, or we also hand USBs back pre-COVID, of course, or there's a version of the code that lives on the lab computer that everyone knows works and can use. And what this touches on is the different requirements that we have as researchers to effectively work together and collaborate. So emailing the script and handing USBs back and forth highlights the need that highlights the need of having everyone on the same page and being able to share easily and keep everyone synchronized. Changing the name of the script to V1 gives us an idea that we need to have a record of the changes we make. That's part of the scientific process, is recording what you do and the transparency that comes with that. But it also highlights this possibility that you need to have your own space where you can make changes and not worry about affecting other people in a negative way. The last one, sharing codes on a lab computer, touches on the need that there should be a version of the code that always works and is accessible by everyone in your lab, for example, or associated with a given project. Because you don't want to show up to the lab for data collection and realize that someone has changed something in a script the night before, you don't know what's changed, and now it's affecting your data collection. So in particular, Git and GitHub have tools and that some of them we've gone over, like having a history of the commits instead of renaming files, and having things on a server as a way to help collaborate. But there's one feature in particular called branches that Git and GitHub use that helps us really collaborate effectively and safely. So when we talk about branches, I want you to think of them as just versions of your repository. These are versions of your project. They're exactly the same, but they're isolated. So a change that's made in one branch does not necessarily affect the change in another branch. It's kind of like a sandbox for you to make changes. If we have a kind of a timeline here where the first commit where a file is added here, and then as time progresses, we'll move to the right. This branch is called master, and this is the default branch for Git or GitHub. And I want you to remember that, you know, version control kind of comes from a software development background, and in that sense, it's easy to understand the need of having a branch that works for your consumer, for your end user, that's kind of outward facing. And the golden rule is to keep the master branch functional to the best of your ability. So if you have some wild idea that might work, it might not, it might break the code, you don't want to test that out in the master branch, because that's what the rest of your team is going to assume is functional because of this golden rule. So that's where branches come into play. So you have the master branch that you want to preserve. However, you can make a branch off of that. So you can kind of split off of it. And let's say this one person in your project wants to create a feature. They can create a branch, and at this point in time, commit 1 on the master branch looks exactly the same as this commit 1 on the feature branch. They are duplicates of each other, but they exist in isolation. So like a kind of a parallel repository. Now at feature branch 1, this person can make changes safely. They can make mistakes even, and they won't negatively affect the version of the code that's like on the lab computer, so to speak. And once they feel like it's in a good place and they've tested it out, they can ask the other people in the project to review these changes, and that process is called pull requests. You're essentially making a request to the project leader or the other people in your repository to incorporate your changes from your branch into the master branch. And this is a very serious thing, because you're affecting the master version that everyone knows you need to keep functional at all costs. It doesn't mean they can't change, but you just don't want to make hasty decisions in terms of updating it. So they will open a pull request. Discussion can occur and say, you know what, well, the changes that you made in C2, I was a little worried about, but you adjusted them in C3. I think this is going to work great with the master branch, and nothing's going to be affected. And so people can kind of put a stamp of approval on it, and then it's incorporated in the master branch, and time goes on. Making branches is really easy in GitHub. And so you can make another branch and try something out and abandon it. If something doesn't work out, and that's okay. You can just delete the branch. The history of it is still there. You can always open it up and revisit it, but there's not a pressure to incorporate it into the master branch. Only once you're confident and the people you're working with are confident on it. So branches is a cool way of fixing problems in parallel. So there's no need to have someone fix one bug, email the script to another person where they pick up where they left off, and email it to the next person, or share it on a Google Drive where people have local copies. You can do that, but the problem is merging everyone's copies, right? And that's what Git is really good at, is automatically detecting the differences in files, multiple files even, and merging them together. And that's what's happening here when you're taking a branch and merging it into the master branch. And so this is kind of a functionality that you guys will get some practice with, and it's a very powerful tool in Git and GitHub. I think that's it for branches and then kind of the core concepts of what you guys are going to work on today. So I want to just move us into the breakout rooms. You guys will break out into groups of 5. We've had your group leaders make a copy of the repository via a process called forking. This is kind of like branching, but it's essentially getting a copy of someone else's project, so one that you're not like a direct collaborator on. So they have now a version of the repository that you are all collaborators on, and you should have received emails on how to become a collaborator on GitHub. You will practice adjusting code, making changes to code, and the story we have for you is that you're working together to produce a figure, and submit it to a prestigious journal for the Nobel Peach Prize. It's a very prestigious award that is awarded to biomechanists who create the best image of a peach using code. You've just gotten some reviewer comments back, and you've decided to make those changes, the reviewer comments suggestions, or the reviewer suggestions, using Git and GitHub, so you can work remotely. And given the current climate with the worldwide pandemic, using GitHub is a viable solution for collaborating remotely. I can speak from experience that we built the content of this tutorial entirely remotely. So Gary was in Boulder, but we hadn't met in person. Same with Ross, as well as Steve Casca has helped us, and he's at the University of British Columbia up in Vancouver. So this tool is applicable to our research, and you can use it to collaborate. It's just getting some practice with it and getting over that learning curve. So the next point I want to make about breakout rooms is that this is still ASB, and we kind of put you randomly in groups. You will all be using the same programming language, but please introduce yourself. You might meet a future collaborator, a future coding buddy in this tutorial. And then lastly, I want to mention the helpers. We have enough to put one in every room, and they will help walk you through this tutorial. So not all of them are biomechanists. Some of them are neuromechanists, electrical engineers, computer scientists as well, or software developers. And so these are all fields that use Git and GitHub to do version control on a daily basis. And I think this is an opportunity for biomechanists to join the ranks, and considering how much code that we write and use. So what my point is that they have a wealth of information, and they will be a great resource for you guys. So ask them questions throughout the process, and they'll help you kind of troubleshoot anything that might come up along the way. With that, let's break you guys up into groups.
Hi, so my name is Garrick Bruening, and I'm going to be going through the Breakout 1 and showing you guys how to do that for the ASB2020 GitHub tutorial. So to start off, the idea here is that you'll have a repository, and you're going to want to make some changes to some code, and then you're going to want to upload all those changes onto GitHub and then see how that changed everything. So to start, hopefully everyone can find Ryan's GitHub repository here. If you can't, hopefully we can provide the link somewhere in the YouTube description or something. So if you go to the repository, the first thing you're going to want to do is you're going to want to create your own version of this repository. This is our master version that we don't really want to mess with. So what you're going to do is up at this top right, you're going to hit this fork button. What it'll ask you is where you want to copy it. So hopefully you're logged in, and you probably just want to copy it to your own account. So it'll copy and make a version on your account that will take a few seconds. Cool. So now that we're here, this shouldn't be there. We're going to want to branch out and assign tasks. So the whole idea is that you created this figure that you're submitting, but we're going to get reviewer comments back. So I'm actually going to show what it looks like first. So I guess not actually. I'm going to go a little out of order here for what we listed, because I want to show you what the plotting does. So to start, we're going to go to part C. So if we go into these tutorial instructions, Breakout 1, this will tell you everything that you would need to know for this, hopefully. So I'm going to start at C, and I'm going to come back up to A in just a second. I just want to get it onto my repository so we can actually see what the peach looks like. Unless it's down there, it is not. So to do that, to get a local copy or clone it onto your desktop, I'm going to hit this code button. This will pop up with a few ways to do it. So you can clone it using the Git bash, download through there. You can open it through Git Desktop, which Ross will talk about later. And then you can also download it as a zip. So I'm actually just going to hit this copy button. And what this does is it copies this link to my clipboard. From there, I'm going to open up Git Bash. Cool. Make that a little bigger so you can see it. And then I'm going to want to go to a directory that I find useful. So I'm going to go straight to my desktop. Some people might have this weird where they need to go to like c:1drive/desktop or something like that. Just get to a folder that you know how to find in your file explorer so you can clone it there. From there, you just want to type Git Clone. And what this is going to do is whatever link I put after this, that'll tell me exactly where to, that'll tell me what repo to download and put. So this is going to be https://github.com/ for me it's gbruening, which is my username, /ASB2020. Hit enter, and now it'll clone it into my desktop. And from there I can cd then into ASB tutorial, and cool. We're now in the repository. From there, I can now see it in my file explorer, hopefully. And I'm going to actually just go there real quick and then open up the main MATLAB script. Let me open up MATLAB. Cool. So now I have the main script open here. I just want to show what happens when you actually run it. So if we run it, change folder to the correct folder path, and then we should get a peach out. Just a second. Cool. So this is what we get when we pull it up. Is we get peach, the ASB2020 peach. The idea of this breakout one, though, is that you submitted this to a journal, you got some reviewer comments back, and they want you to make some changes. So I'm going to show you how to go through and make those changes now. So close MATLAB, close the peach, and then we're going to go back to our ASB tutorial. So in here, in the tutorial instructions folder, we have a reviewer comments. So from reviewer comments, general comments, you know, we want to win the Nobel Peach Prize, and then specific comments. So in script 1, we're going to want to change the color of the peach to that, change the color of the leaf, change all the outline widths, change the ASB text color, and then change the year to reviewer 2 is the best, so not a year. So how we're going to do that is within GitHub, we're going to create branches, and then we are going to edit everything in those branches, and then we are going to merge all those branches back into master. So to add a new branch, we're going to go here, find or create a branch, and then we are going to type in, let's say we want to edit script 1, so I'm going to just make a branch called script 1. Cool. And so now if I click on this again, I'll have 3 branches. This presentation handouts is vestigial from our master branch, and script 1 is the branch I'm going to use to edit my scripts. So once I'm in script 1, what I'm going to want to do is then in my git bash, I need to pull and then cd in or change my branch into script 1 so that I can then edit it safely without altering the master branch. To do that, I go into the git bash. Let me open that again. Cool. And then just do git pull just to make sure I'm on, everything's good. So what it told me is from this URL, we had a new branch show up, script 1. Cool. That's what we'd expect. From there, I'm going to say git checkout. And so git checkout will allow us to switch to a new branch, switch to a new checkout state or a commit state. This is good for reverting changes or whatnot, but I'm just going to do git checkout script 1. And so what you'll notice is this right here will change from master to script 1, letting me know that I'm actually in script 1 territory. So I can edit things without destroying the master copy. This should also show up in my file explorer and my MATLAB. So I'm going to go over to MATLAB now to actually change the file. Let's close Chrome, open up MATLAB. And if I go into the MATLAB scripts folder and then into script 1, we are in script 1. So if we go, remember what the reviewer comment said, I believe it was to change the color of peach from 0 to 0.5 something. If you get stuck on how to actually debug these, we actually just posted the solutions down here. So if you really want, you can just copy the line that's going to be changed, copy that, and then I'm just going to paste it there. Cool. So script 1 is now saved, but we now need to tell Git that we changed something and we want to change the branch. So it's changed in our local repository, but we want to change it on the remote repository. So what we have to do is we have to git pull and then, git add, commit, and then push. So I'm going to go back from, actually, let's show what this changed actually. So if I run the main script again, cool. Show the peach. Peach is not there. Just a second. We show the peach. This is what the peach looks like. So we changed the color from a nice peach color to a purple color. Kind of unclear why we did that, but you know, review or two. So from there, we're then going to want to tell everything that we made this change, and we want to upload this to GitHub. So I'm going to go back into my Git bash area. I can make this a little bigger now, so it's hopefully easier to see. And then from there, I'm going to type git add dot. So what that does is it's going to tell Git to look through all my files and see what I've changed. The dot indicates just look through everything. Everything in this repository, look to see if anything got changed. You can do specific files. So if I did git add script 1 and I was in the correct directory, it would only add script 1 to this. So it would only check script 1 to see if anything was changed. But I'm just going to do git add dot because it's relatively easy. It doesn't say anything, but what we can do is we can do git status. Once I do add, I then want to do git commit. So git commit, and then you want to do -m, and this tells it you're going to add a message to it. And then in quotations, I'm going to say changed peach color from peach to purple. Cool. What this is going to tell us is that cool, script 1 got changed. This is the message I sent. I only had one file changed. It had one line of insertion and one line of deletion, as we'd expect. We can then run git status. What the heck? Again, it's not there. I don't know why. So once I've added the commit, then I'm going to want to push it. So git push. It's probably going to tell me, oh, cool, it did work. Sometimes you will get a message here saying you don't have the upstream set correctly. If you didn't branch out first or something, or you built the branches through git bash, it'll give you a message that's about git push set upstream origin. Just copy that and paste it here, and it will set the set where to push the stuff to. So this is telling me did a bunch of stuff to see if it added it, and then remote resolving, and then it's saying it pushed to it with this commit hash. Script 1 got changed here. So now I'm going to go back to Chrome and see if I actually changed something. So if I go back to my code, I have this notification here saying script 1 was changed. Great. And this is saying script 1 is one commit ahead. So what I next want to do is we have these two branches still where you have script 1 and master. We want to make these changes from script 1 to show up in master. So if we go to script 1 and we actually go into MATLAB scripts, you can actually click on this and you can see the code here. So you see that yes, it was changed, but if we change our branch to master for the same version, it's actually not changed. So what we're going to have to do is we have to create a pull request from script 1 into master. So I'm going to go back to my code. I'm going to hit this compare and pull request button. If that button is not there, you can also just go to branch 1, and this should always be here. If it's not, you can hit this pull request button right here as well. So I'm going to hit pull request. The key here is that you can't just hit this pull request button. There's one thing you have to change. So right here, you have to make sure you change your base repository. So with forking, there's this idea of you have your own repository, but also if you make changes, you can ask to be pull requested to the master version, so our version. If you found something wrong with our code, with our instructions, you could actually change it in your own version and then make a pull request to our version along with your own personal version. So I'm going to go here. This will just have all the different forked versions, but I'm going to choose mine. It should do some things here to clean this up a little bit, and then you can make comments, you can change the name of it. I'm just going to hit create pull request, and that's going to make it. So it's going to open up a new window. It's going to do some checking to make sure it'll work, make sure there's no merge conflicts. And I'm going to say merge pull request, and then confirm merge. Cool. So it says pull request successfully merged and closed. You're all set. So now what this should mean is that the peach color should have changed in the MATLAB script in the master branch. So if you go to MATLAB scripts, script 1, you'll notice that the commit message here has now changed. So it changed peach color from peach to purple. That was done about 4 minutes ago by me. So if I go in here, great. The color change now shows up. So that was a single script. You would go through and do this for all 5. And then you could run it to see the final product. I'm going to pause the recording now, and I'm going to go through and do that just to change everything. And then I will hop back in and show the final product. All right, so I just went through and branched out, made all the changes, and then pushed all the changes up, and I just need to pull request everything. But just to recap, what we do is we go into this, we hit this button right here to create our branch. We create our branch that we want to do our debugging in. We then change everything in our text editor. I was using MATLAB. Then we do the Git Commit, Push, Pull in Git Bash. So we do Git Add. Then we do Git Commit to add a message, and then we push it to our remote repository. From there, we then need to pull request. So I just need to go through and hit compare pull request for all of these, create pull request, merge pull request. I'm going to pause again while I do all this just to speed things up. All right, so now that everything has been merged back into master, one thing we can do is we can go check the commits. So by hitting this button just to in this blue bar to the right, I can actually see what I've committed. So in the past, it was change year to review 2 is the best, and then merge pull request number 2, number 3, number 4, and number 5 back in. So you can see the history of what you've done, which is very helpful. This is the commit number, and this can be useful for if you need to undo a commit or you need to check out to a state to see what was going on during that. And you can hit this clipboard to copy that, or if I want, I can hit this commit, and this will actually bring up a new window showing me what I've changed. So this is telling me this was the old version where I had plot this, and I changed this K to R and then added the comment for that. So that's very useful for tracking what was changed. So I'm going to go back to the main one. So now in Git Bash, what I'm going to want to do is I've already done this, but I'm going to want to check out to the master from whatever script I was on, and then I'm going to want to Git Pull. So what this does is it's going to update all of them. It's going to update that script 1 was changed, script 2 was changed, all of those in the master branch, and then say, okay, cool, we had 5 files changed, and this is how much you changed. From there, what I can do is I can then go back into MATLAB, and if we go into the MATLAB scripts and we say go to script 4, for example, we can see these changes and that it was changed to red. So we have all the changes from our pulling and pushing, and now I'm going to run the main script just to show the final product that reviewer 2 wanted. Yeah, no, a great product. Let me just pull it up, window capture, yep. And this is what he pulled up. So reviewer 2 is the best. So this is a tutorial, the Breakout 1, and how to do all of the instructions. So hopefully the instructions and the video will help you get through this. I think Ross is going to be up next with some considerations and a recap of what we did, and then we will go into Breakout 2 to undo all of these changes that were made.
Hi everyone, my name's Ross Wilkinson. I'm a postdoctoral researcher at the Locomotion Laboratory at CU Boulder. I hope you've all had some wins in that first breakout session. My job here in this break is to give you a quick recap of what you've just learned, and then also introduce you to what you'll be doing in the next breakout session. So I'm sure with your first taste of version control, you've got a ton of questions, okay? Due to time constraints in the tutorial, we're probably not going to have time to answer all of them right now. We hope that your instructors are going to be able to answer a lot of the technical questions you might have. For the more general questions, please try to remember them, post them to the Q&A forum in the main chat room, okay? And hopefully we'll have time to address maybe a couple at the end, but if not, we're going to produce a Q&A style document that we're going to send out to all of you after this tutorial. So a brief recap of what you've just learned. You cloned a repository, okay, to create a local copy on your computer, and then you were syncing between those two locations. What you went through is what's commonly known as the GitHub flow. The first step in that flow is to create a branch, which creates an environment for you to try out new ideas and experiment, okay, before really committing any changes to that main branch. So you can make changes on that branch and know that nothing on that master branch for the repository is going to be affected. Once you've made that branch, the second step is to start editing, okay? You're gonna make some changes and then you're gonna commit those changes. Whenever you add, edit, or delete a file, you're making a commit, okay? And then you're adding them to your local branch. And this process keeps a track of your progress as you work on that branch. It creates a really nice history, okay, of your work for others to follow and understand what you've done and why. The third step after you've made any changes and committed them is to open a pull request. This is going to initiate discussion about your commits, okay? Your team members are going to be able to look at what changes you've made, and they can accept that merge if they want. And don't be afraid to use pull requests sometimes to just share ideas or even screenshots. It can be used for things like that as well. Once you've opened that pull request, you're going to merge it back into the master branch. If there are any conflicts, GitHub is going to flag that, okay? If not, those changes will get merged once accepted with the master branch. That's going to preserve a record of all of those changes, okay, that you make to the master branch over time. The final step is both tidying up and then syncing between the local and remote repositories. So first of all, you wanted to delete those branches, okay, they're dead, they're done, you want to get rid of them, and then you want to sync between the local and remote repositories. If your team members, for example, have updated other scripts, you want to pull those down to your local machine. Just a very quick, simple diagram to somewhat illustrate what you just did with your team members. So first of all, you cloned the repository down to your local system, your local machine, and it had branches already for you to each of you to work on. So you worked on those copies, okay, you worked on those branches, and then you fixed the issues within each subscript on that local branch. You then pushed them to the remote local branch, and you each opened and merged a pull request to then finally merge back into the master branch. You then tidied everything up, deleted them, and synced between the local and remote repository again, so that you could then see all the changes that your team members had also made to some of the subscripts. Just quickly, some other considerations that we'll probably expand on in the Q&A document that we send out. So when should you commit? There's no right or wrong answer to this. A lot of people have different opinions. Some people, first day on the job, you want to make a 3 a.m. commit just to let everyone know that you're committed to this work, okay? There's going to be a whole variety of reasons why maybe you want to commit very regularly, or maybe you want to make larger commits that are somewhat more significant for your team members to read. So it might be a matter of whether or not you're collaborating with yourself, or maybe you're collaborating with a larger team. When to pull, and then when to pull request, okay? So it's a great idea that when you first sit down to start working on anything, is just get in the habit of pulling the remote repository, any changes in the remote repository, down to the your local machine. You really don't want to start working on something and then for a conflict to happen later on because you realize you're working on an old copy of the repository. Pull requests are a little different. So pull requests, you don't want to prematurely create a pull request until you really want people to review that work. So once you create that pull request, people are going to be able to review that work. Okay, so you just want to be aware of that. Some teams will have kind of rules around that they might enforce on people working on that repository. So another question is, what if there is a conflict? Obviously, you don't want to panic. This is a fairly common issue, and it's not like you have to choose what stays and what goes. You don't have to lose any work that you or someone else has done, okay? So you have the choice to choose what stays or what goes. You're not going to lose any work on the master branch or on any branches that have been created. Finally, what if you do share sensitive information? This is a real thing. It is an issue with GitHub sometimes that when you make a commit, that it will carry with it some login credentials. Again, fairly common issue that many of us will experience, and Git and GitHub provide very easy tools for you to go back, look through the history of the repository, and remove any commits or pull requests that may have contained sensitive information. All right, so it's time for you to go back out into another breakout room. So we've all had that oh crap moment, okay, where we've needed to go back to a previous version of our work and realize that collaborating either with ourselves can actually be a real nightmare. So luckily for us, GitHub makes it quite easy for us to go back to a previous version of our work, okay? So what you're going to do, you're going to jump into your breakout rooms again, you're going to collaborate with the team, and this time you're going to revert the changes that you just made because reviewer 2 comments were clearly rubbish, and you want to make that figure great again. You want to make it or turn it back into the original orange logo. Okay, so just a couple of things to remember. You want to use the Git cheat sheet if you get stuck. Okay, those commands are there for you to look at, and you're going to realize that the GitHub flow in this case is a little different, and you're going to learn a little bit about the mechanics of what reverting those changes or how reverting those changes works. All right, so good luck, and I hope the second breakout session is successful.
Hi, so for breakout 2, the idea of it is that your figure got rejected and you now want to go and undo all of the changes that reviewer 2 suggested. So to figure out what we need to do, I'm going to hit the tutorial instructions again and go to breakout 2. So this kind of describes all the process to undoing it, and we're basically going to want to revert all these recent pull requests. So all those pull requests that we did in tutorial in breakout 1, we're going to want to undo all of those. So how we're going to do that is I'm going to go to these pull requests, and we have 0 open and 5 closed right now. So we're actually going to hit this closed version, and these are all the pull requests for everything I changed. So this was for script 1, script 2, script 3, 4, and 5. And to revert them is relatively easy. So if we actually go into the pull request, we have a few things that we can do. So you can delete the branch. So this branch was associated with this pull request. If we're sure we're never going to use this, or if we're sure we don't want to use this for a while, we can delete the branch. You can restore the branch later. But what we're looking for is this revert button. So what this revert's going to do is all these changes that were made, so only one change, this change right here, it's going to revert that. If you actually click on the change, again, it'll pull up a window that'll show you everything that you've changed, which is very useful. I'm going to go back though. I'm going to hit the revert button. So what this is going to do is it's actually going to create a new pull request that has a commit that's basically the opposite of the previous pull request. And what it's going to end, so it's kind of redoing the undo. So it's doing, yeah. So if I hit this create pull request, it will create a new pull request and it will say reverts number 1. So this is saying pull request number 1 is going to be reverted. And then I'm going to do confirm merge. And that should undo it. We can again look at the commits, so revert the changes, and it's going to say files changed. So what does that change? Well, we see here that this was what it looked like after Breakout 1. So we had the peach color as this weird purple as per the reviewer comments, but we're just going to undo that and change it back to what it was before. I'm going to pause now while I undo all the rest of them, and then I can show you the final product. So once you've merged all of it, all of those, or reverted all those changes, and you go back into pull requests, you should see that you have 10 closed. These first 5 will be those first merged pull requests from the reviewer comments, and then the second group of 5 should be reverting all those changes. Our local version, though, is still not going to know about this, so we need to make sure that when we actually plot the figure again, that we indicate all these changes to our local. So I'm going to open up my Git Bash again, and then from there, I'm just going to do another Git Pull. Cool, it's going to tell me all of these things changed. I can read this more in detail, but for now, we don't really need to worry about it. Mostly just know that these were changed. So cool, all of our scripts were changed again. And then I'm going to go plot it in MATLAB. So open up MATLAB again. I'm going to go desktop and then ASB tutorial and go forward again. And if I open up the main script and then I run it, let me add the window again. Page 2, I guess. We can see our final output product is back to what we'd expect, which is great. That's what we want. So yeah, I think that's really it for Breakout 2. It's a little bit shorter. And I'm going to talk a little bit now about what we did. So I'm going to give a recap, some additional Git functions that we didn't really go over yet and what they do. So yeah, that was Breakout 2. So hopefully everyone was able to mostly complete Breakout 2, where we needed to undo all the changes that Reviewer 2 requested. So we did that through the GitHub website by reverting all the pull requests. So I'm just going to give a brief recap of what we went over and what we did. So we started with this beautiful peach that we were submitting for the Nobel Peach Prize. We got some reviewer comments on commit 2, we can say. So we did is we identified all the issues that we wanted to change, we branched out, and we made those changes. We then merged these changes back into the master branch using pull requests. And that was essentially Breakout 1, where we ended up with this peach. We then wanted to think, oh no, this is not actually a good peach, so we want to undo all these changes. And that was essentially Breakout 2, where we undid all these changes to get back to our initial peach state. So we did this through mostly GitHub and Git Bash. But there's a few extra Git functions that I'm going to want to talk about. So let's say we have this branching pattern here. So we had our initial commit here, made a little bit of changes to the master, and then we decided we wanted to add features. So we branched out and we made 3 and 4, where 3 was some change, and then we approved this change and we merged that back into master in 5. Well, now branch 4 has no knowledge of what happened in branch 5, or sorry, in branch 3, or in the master branch with 5. So what we're going to want to do is we're going to want to merge it back into branch 4. So branch 4 is going to want to see what happened in 5. And this is done through git rebase. So what we do is we type git rebase in either master or branch 3, for example, and any change here will then be applied to 4. And that will give us a new branch where all these changes in 3 and 5 are now included in 4 in a new commit, for example. We then can test all of these features that 4 was working on to make sure that there's no conflicts, and then this can be merged back in into the master branch, and that's called git rebase. Another method, so we talked a little bit about how to undo changes, and we decided to just do undoing pull requests by reverting. There's other methods of reverting specific commits or specific pull requests through the git bash. But let's say we didn't like this last commit, so that would be actually this whole commit right here. And we can just do git revert and this specific commit. And that will actually basically undo anything that that specific commit had. This can cause merge conflicts a lot of the time, as it actually doesn't see that something changed. So be careful using this. But I think Ross will talk about merge conflicts, or Ryan has. So yeah, what that'll do is that'll undo 7 and basically revert it back to state 5. Another way is you can check out to an old commit and then recommit that. So git checkout, you use this to make your branches, and you can use this to undo a lot of changes all at once. This is useful to go back a lot of steps, whereas git revert only undoes 1 step. So with git checkout, if we wanted to go from 7, go back a second. So if we were at 7 and we didn't like any of these changes and we wanted to go all the way back to 2, you can just do 1 git checkout commit to go all the way back. So you git checkout, find this commit's hash, git checkout to that, and then you git commit that new that as a new commit essentially. We didn't do this in Breakout 2, but this could have been done in Breakout 2. But we wanted everyone to have some practice with undoing commits, so we decided to go for the undoing pull requests. Some additional features of Git and GitHub that might be useful to you are issue tracking. So issue tracking is crazy powerful. It's a great way to track bugs. It's a great way to think if you have an idea for something but you haven't quite figured out how to do it. You can post it, put it in issues and say, I need to do this, this, and this. And then you can track it in through GitHub. It also has the thing where you can assign tasks. I'm actually going to show you how to do this in Chrome in the GitHub thing. So if everyone followed our tutorial, you actually forked these versions, and you won't actually have that issue tracking there. Issue tracking is really only for the base. So when you create your own repositories for your own code, you'll have this. So I'm going to go to Ryan's ASB tutorial, and up here now we see the Issues tab. So if we go into Issues, we apparently thought of something after the tutorial. I'm just going to go in here, and Ryan made something saying, hey, we need to do this. I'm actually going to go find a closed issue where it was useful. This one was probably one of the more useful ones. So early on, we decided we needed to create Python and R scripts for this tutorial, and we did this. You can label it. You can add things. You can add comments to it. So this hash refers to a pull request. So this is saying at pull request 10, we did something referring to this. You can also link to specific commits. So this was the initial commit of adding the Python scripts. And then we decided we needed to change things so we could talk about it here. We could keep track of everything. And then Steve came in, edited them a lot, and uploaded them. And then you can close them with a pull request. So this was in reference to a pull request down here. Along with that, on the right-hand side, there are these useful things where you can assign people these tasks. So if you need a specific feature that someone was working on, you needed them to track it in the issue, you can assign them this. You can add labels to it. So this was an enhancement to the Git repo, as it's a new thing. You can also, if a bug is there, documentation, there's tons here that is great. You can even make your own label. This project and milestones thing, we didn't talk about this very much, but this helps if you have a very large project. You can assign a project and they say, hey, this issue is addressing this part of this project, and so on and so forth. So that's issue tracking in GitHub. I think it's great, super powerful. So the other thing that's really useful on Git, you can do this in Git Bash, but the UI is not so great, I think. So I mainly do this in GitHub, and it's viewing commit history. So I showed this a little bit in the Breakout 1 and Breakout 2, how you can click on commits and see specifically what changed. Come on, next slide. So when you actually go to you view all the commits, you can see, you know, we merged pull request this, and then it was verified, and you can see the commit number, and you can see a huge history of it. This is, Ryan probably touched a little bit on this, of why it's important to have good commit messages. So this is a different repo that me and Ryan worked on. And for example, this commit message, probably not that useful. What's LFS? Question mark. It doesn't really help that much. The delete temp files star-.vs, actually really good. Tells me exactly what he did. If we wanted to keep those .vs files, you could just go to that commit and undo that commit. And specifically in that commit, when you're viewing these changes, it pulls up this new window, which is really cool, and it shows you actually exactly what was changed. So this tells us line 191 through 190 on the left side got changed to this new one. So this is from our topic modeling prediction algorithm, which is on GitHub as well. So I'm going to show this a little bit in Chrome, or on actual GitHub. So if we go to the ASB tutorial, near the top, you can see this button with 162 commits. So if I click on that, I bring up a new window, and again, it's all of these. So these are recent from today. This was me messing around with stuff, but it goes, you know, all the way back. You can keep going down, older, and this should keep track all the way to the beginning of the repository. So you can realistically see all the work. I'm going to go back to here. So once you're in here, you can click on this button to copy the commit history, or you can click on either here or here to view the actual commit. So I'm going to click on here, and this is going to tell me exactly what files he changed. So in this one, he changed the main MATLAB script, and he changed how the add paths scripts were going. You can do this over here as well, and it does the same exact thing. This button will let you copy it to this number to your clipboard, and this can be useful in Git Bash when you are trying to move to a different Git commit. So like if I thought all of these changes were just awful, what I can do is I can say, okay, this is the last state that I liked, and this was good. Do this, go into my Git Bash, Git checkout, control paste this commit number, and then from there I can commit that as a new commit, and that will basically revert it back to this state. You need to be a little careful, again, doing this with merge conflicts, as that can come up frequently when doing that method. So I think that's all for my additional GitHub stuff and things that are cool on GitHub, and I think it's on to Ross. So on to Ross. Thanks.
What I'd like to do now is share some tools and examples of how easy it can be to integrate Git and GitHub into your workflow. We obviously all want our general workflow to be hassle-free and productive, but there's also some nuance to each of our needs that we obviously have to consider. There is no shortage of options when it comes to software tools for using Git and GitHub, but this obviously comes with a wide array of opinions as well. Many people still use the command line because there is the full suite of Git commands available, but there are some other options that, in my opinion, can make your life a little easier. One of those is GitHub Desktop. It's a convenient offline portal, and I think it's quite convenient for creating and accessing repositories. The second category are GUIs. So for people working on Mac, Windows, and especially Linux, some of these GUIs are going to be necessary for you. There's, again, a huge range of available free options. The IDEs that we use, so for example, MATLAB's GUI interface, PyCharm, a lot of the modern text editors like Visual Studio Code and Atom, all offer GitHub integration, which can make your life very easy. And it means that you can just keep working away in that IDE throughout your workday. What I'd like to do now is just provide some screenshots of me using some of these tools. First is GitHub Desktop. What you're going to see here is I'm going to just create a new repository. Okay, I've downloaded GitHub Desktop onto my Mac. I've got it open and I'm going to create this new folder. Okay, this new project. In this case, I'm working on a new Arduino project. I'm going to provide a nice basic description of what this repository is going to be used for. I'm creating a local path actually within my Google Drive folder, and I'm initializing that folder with a README and also a license. I'll then publish that repository to GitHub, all in the space of about 40 seconds. And you will see that it's all ready for me to start working now in my IDE in a very short period of time. Next, I want to show, given that a lot of biomechanists are working in MATLAB due to obviously the popularity of MATLAB itself, but also Simulink, I want to show the integration that is available within MATLAB. So what I'll do here, within the folder I just created using GitHub Desktop, I'm going to create my first script. Obviously a very basic one just as an example. So I'll type that out. I'm going to save that script into my new project folder, which is on my local machine. And now what you can see here in the current folder, you've got a white circle, which is going to show that it's actually, this new file is not under source control. So you're going to add that new file. You're then going to commit that change, putting a nice descriptive message. You can notice that the Git commands are prefixed by an exclamation mark. You'll then push that change up to your remote repository. And finally, we'll just check out the remote repository just to make sure everything is up to date. The only issue with MATLAB for a lot of biomechanists is that the editor window isn't really compatible with any other programming languages. For that purpose, I tend to favor Visual Studio Code. For example, a lot of people are shifting to Python. A lot of people are using R for their statistics. So what you can do with Visual Studio Code is pretty much anything. It's an extensible text editor that people are writing extensions for all the time, and it supports a huge range of programming languages. The GitHub integration is also extremely simple and easy to work with. What you'll see here is me creating that same file again in the new Arduino project folder. I'm going to create a new file. I'm going to tell Visual Studio Code that it's a MATLAB file, and that way the text editor is actually going to be able to operate on my code as though I'm working in the MATLAB editor. I'll save that file again, and we can see that the left-hand column where I've got my GitHub extension is going to notify me that there is a change that needs to be staged and then committed. So I'll first stage that commit by clicking on the plus button. I'll add a similar commit message. I'll click the tick, And then down the bottom in the blue bar is actually how you sync the local and remote repository. So just click and point, very simple integration, and has definitely made my life a lot easier when working on code. Finally, this is I guess an integrated workflow setup that I've been trialing for the last month or two. It's one of a whole range of options. So some people, Visual Studio Code, I understand, isn't going to work for you. I also understand that Google Drive may not be optimal, but things like Dropbox, OneDrive, all of these other similar tools, you can just substitute them into this workflow, and hopefully it works for you. And I'd be really interested to know if anyone has some ideas for this as well. So first of all, you can program in Visual Studio Code. You can use GitHub for the code management. You can then use Google Drive for data storage and also collaborative writing using Google Docs. Then Slack is a program that you can use to communicate with your team. So it's going to be really handy for communicating to-do lists or assigning tasks. There's a little bit of overlap there with GitHub. So yeah, it's really about just experimenting with these workflows and figuring out what works for you. But this might be just one option to start with and see how you like it.
Some options for implementing version control with projects that aren't code-based. I know a lot of people write manuscripts. This is kind of the bread and butter of our field. And I want to mention that Google Drive actually has some features that are version control related. So if you are on Google Drive and you right-click on a file, you can see a button that says Manage Versions, and you can see that there are versions that are saved here, for this given script. There's not a ton of information about the line-by-line changes like we saw in GitHub, but if you're trying to track a PowerPoint file, file, or something else that's not like a raw text file, Google Drive actually allows you to do this. If you are trying to collaborate using Word Docs, something that a service that I've been using recently is called SimilarDocs. It's free if you're trying to collaborate on one document at a time, but if you need to do multiple ones, they have packages and deals for academics. But what it is essentially is the version control concept that I explained, even with branching and merging, but with just Word documents, and it's web-based. It integrates well with Google Drive, and I've been using it for my most recent manuscript. So definitely encourage you guys to check that out if Word is your word processor of choice. If you use LaTeX, you can use GitHub. It's essentially code. It's a raw text file, but you can also use Overleaf, and that has some nice integration with their service as well, where it's versioning, or sometimes it'll be called like source management. So with that, we'll call it the end of the tutorial. I want to thank you all for your time. And again, if you have any questions, you can reach out to me on Twitter or via email, as well as Gary or Ross. So thank you again, and have a great ASB.